All right, interest in this digital clock dropped off. I think what happened was YouTube featured one of the videos. They do that every once in a while. Like they actually, part two got featured and it got a lot of hits. Meanwhile, part one didn't get any, almost no hits. Part three only got a few hits. But as you can see, this is counting to 8, 9, 10 o'clock, the 1 comes up, 11, 12, and then it goes back to 1. There is on the driver chip for the LED, there is a blanking pin. I didn't want to do that yet because it would confuse you. Anyway, you can make it so this 0 goes away while when it's not at 10 o'clock or 11 or 12 o'clock, okay? But I just want to show you. Now off here, you can see this is count and locking. They're identical circuits. This worked. This didn't work. I moved chip from over here to over here, and this worked. All right, what I found was the guy's logic. Once again, it was Indestructible's 12-hour clock, 12-hour TTL clock. He did the circuitry on the simulator, and simulators aren't always perfect. Or most of the time, they're not even close, okay? And people design circuits on there, and then they draw them up, and they post them on the internet. In this case, the guy actually wired it up. But what happened was he used a 74LS90 chip, and it worked for him. Now, I went through a bunch of different chips, 74LS90s. I only had IT&T brand. Well, that's a really off brand. I didn't have any like Texas Instruments. So I went and used Texas Instruments TTL, made in the United States, and they work perfectly. Okay? The other brands that were made like Malaysia, they don't work. Now, what is actually happening is he's taken an AND gate off the 7490. He's taken two pins, I believe it'll be 12 and 9. Well, anyway, he takes those two pins. Well, those two pins have to be high at the same time, along with this second IC that has to also be high at the same time, and then it does a reset. And the guy is using a trick circuit. He's using the 9 set besides the reset. So the 9 set pins are tied to the reset. So pins 2 and 3 and 6 and 7 are all tied together. And when this clock goes through its motions, or this 12 o'clock section goes through its motions, it does a reset, I think twice. All right. But anyway, I just want to warn you, if you should build a circuit, make sure you got several different brands of 7490. And I can change them, and each one I change, different brand, does something different, even though the wiring in both these circuits. If I put a certain brand 7490 over here, it'll do something wacky, but it'll do the same wacky thing over there. And that's because the two pins that are going to the AND gate, that's where the problem is. The third signal is very slow. So the two pins have to be high at the same time. And they use the word settling time. Your two outputs that go into something have to settle, and they have to be low or high or low for a certain amount of time when something else happens. Otherwise, you're going to get erroneous data. That's the actual word they use, erroneous, back in the old days. But, you know, I'm sitting there going, I wired this wrong. And right away, it's me. Okay, I'm 70 years old, and I'm salvaging wire wrap wire, and I'm in there, and sometimes you count the pin the wrong way. You know, so then you got the wires you put on. I catch it because I keep double and triple checking everything. I catch it. Okay, I daydreamed. I put that wire in the wrong spot, and then I get it working. And as soon as I turned it on, it was doing this weird thing over here, like over here. And over here, I put a socket in because I thought I was just making bad contact with the not wireless proto board, solderless proto board. And I put a socket in there, and I went through the 7490s, and I got one that worked. And I'm like, I must have bad soldering, or there must be black on the leads. That's why I got the idea to show you how to clean the leads. And what it is it's just not a great design. It does work, and it's very slick when it works. okay? Because the amount of chips you need to do a 12 o'clock section on a digital clock, there's a lot of chips now. This guy, by doing what he did, he really cut it down. Now, he did it on the simulator, and then whatever chip he used, which was he used the 74 LS90, it worked, and he did it on a proto board. In the picture, it's on a proto board. So it worked, and it did work for me. Okay, once I changed the chip, I thought it had some bad chips or bad connections. Put a socket in there. I put in a Texas Instrument chip made in the United States, and it started working. And I said to myself, don't take that circuit apart. Because if you get over here and then this don't work, you'll be, and I was pulling my hair out. I was buzzing, I was going back and forth, I was ohming everything out. And I'm like, it's right. So I said to myself, you know what, I got some type of delay error. And that's when I started changing chips. And all of a sudden, I'll look over and this thing's working. I'm like, wait a minute. And I look, I put in a Texas Instrument chip. So I went digging, and I found 3 more of them chips. And actually one was over here. I found 2 more, and then I moved, and everything started working. All right, now I got a handle on what the hell's actually happening. But there is a way on the 7447 to blank the leading 0. So in other words, you see the 0 there, that's there most of the time, except at 10 o'clock, here we go. 10 o'clock, 11, 12, back to 1, but the 0 comes back. You can blank that out. But I just want to leave the 0 there to show you this is how most people's clocks work, the circuits. This always stays at 0 at 12 o'clock, okay? Actually, both digits are 0, 0 at 12 o'clock. It doesn't count up like this does. That's what's so unique. And I told you, the clock in RCA that Charlie Trischel had, and I'm pretty sure he designed it. I can't find it anywhere. I can't find any schematics for back then that were unique at what he had. He had TTL chips in the 12 o'clock section. Okay, that's the uniqueness of it. Now, if you got an RCA clock with pneumatrons and it was made at RCA, you're going to have those TTL chips on the circuit board. And you're going to have an SCR down in the power section, a little tiny SCR, and that's supposedly going to fire with off the AC, and it's going to send a pulse out to your first 7490. All right, but it doesn't. What's actually happening in that circuit is the AC is getting into 7490 and it's counting it. Okay, and I said that to them. I said, I put a scope on the circuit, and they're looking at me. The guy, and he's like, well, then he got his scope out. And he realized that the circuit he designed wasn't even firing. And it's pretty interesting. I wish I had that schematic. Knowing what I know now, I could probably go back and get that SCR to fire. But there's no way I'd ever touch those DTL chips. That was a nightmare. Okay? Now this clock here, to work correctly, has 13 chips. Okay? It has 10 chips less than the RCA clock. And the reason is I don't have that wacky 12 o'clock or 12-hour section, and I don't have the seconds. And oh, I wanted to tell you, I'm operating this in seconds. I have a jumper to hit this section with the 1 pulse per second, just so you could see it come around a few times. Okay? Because if you put the rest of the chips in, you're going to be waiting an hour for each transition. And that used to be the word transition. Oh man, all the different buzzwords we had when our digital first came along, and they made it difficult because the guys that could do that stuff they were different. They were like programmers. Nobody knew what they were doing. So I told you I got that TTL cookbook, and the remnants of it I'm using right now. Here's the carcass of it. This book has been used so many times. Oh, and you get it free online. It is free up online as a PDF. Very good book. Each chip's got a diagram, and then usually down here it tells you have to have 2 highs, 2 lows, or whatever to get the output to change. Now an AND gate is if input 1 is high and input 2 and so the inputs 1 and 2 and are high, and the output would be high, the output. Okay? There's no inverter. If you put an inverter on the output, it would be an AND gate, and it would have a different part number. Okay, digital logic. When I first was learning it in tech school, I thought the guy was double talking. You know, A and B, and then it was a nightmare. And then he got into Boolean logic, and this guy was teaching it. I don't think he really was that good at it, but nobody sitting there was like, "Oh man, this is hard," you know. But it's fun stuff, and I got it done. I stayed with it, and the next part is to clean up a little bit, and then to figure out how to shut this leading zero off. Maybe go around the clock one more time. I might want to put a pair of flashing colons in between the digits. But you got to remember, I only built this circuit to see that 12-hour section work. When I saw, well, first I was trying other clocks, other circuits, and they were giving me 0, 0. And I'm like, no, what? And I couldn't find one that, I found one that did it, but yet there was a trick. You rewired the Nixie tube wrong. And I'm not using Nixies, I'm using LEDs. But probably to build a true digital clock, what would you call vintage, you probably should use some Nixies. And go look at the price of them things up on eBay. Now, a couple of years ago, you could get Nixie tubes from like HP stuff, and they were plug-in boards for different test equipment. And they'd sell you just the Nixies plug-in for like 10 bucks. Forget that. Okay? That's why when I started building this, I wanted to see that 12-hour section. And I kept saying, I can't see it. In the diagram, I couldn't understand how it could do 12. Well, it didn't. And it wasn't me. And, you know, like I told you, at my age, I start doubting my abilities now. And you'll hear me misspeak in my videos. And that's because you get old. And when you look at the video, you know exactly what you thought. But what you thought and what you said are two different things. It's amazing to see yourself slowly decline. Okay? And that's why if I'll mention Social Security, people telling you want to work as long as you can so you get the most money. Yeah, you'll get more money. You won't know who the hell you are, or you'll be dead. Okay? I told you I walked with that guy. He went to 69 years old when he decided to retire. By the time of the paperwork and everything, he got 1 year of retirement. Walking around, he got lung cancer, Agent Orange, or he was a smoker. One day, he was telling me about the price of cigarettes over the years as a smoker could do it. And he kept asking me if I smoked. I said, no, I didn't. I'm like, so he might have been a smoker for years, and he was worried that he would get effects from it, and he did. But he was in the, Vietnam, and when he was in Vietnam, I don't think they were spraying Agent Orange, okay, the year he was there. So I don't know. And then his brother said he used to hang at Smoky Bars. So he might have been one of those people that was a smoker only when they were at the bar, or they're secret smokers. I lost a cousin that was a secret smoker. Actually, my sister, who died from smoking, she was a secret smoker. My parents didn't know she smoked until she was 30-something years old. And then my mother caught her, and then she confessed. Think about that. That's the people that were around me, okay? I look back on it, man, I had, the most sensible person was Ken Recor in RCA, and he basically explained the world to me from a person with a good grasp on reality. But he also, when he had a problem, I told you, he would make paper airplanes and throw them out of RCA windows, and the police would come and pick them up. I told you that story. But anyway, so how sane he was, I don't know, okay? He did have a son. The last name was Recor, R-E-C-O-R-R. You might find a picture of him in an RCA pamphlet. He is in one of the pamphlets I found online. But he explained a lot of stuff to me over the years that I worked with him. Actually, it was 1 year and 9 months, but it made a big impression on me. How smart he was, how he approached things, and he knew that I would stay with something until I figured it out, and I would ask for help. The one day I had somebody bought the wrong terminals. I put them in a bin, and one of the terminals was broken, and I put the new terminal in, and the new terminal strip had a ground lug or a attachment point that was actually grounded, and I didn't see it. And I got a short, I can't find the short, and then the guy next to me, Joe, I said, Joe, can you look at this real quick? He found it like right away, and he goes, something's wrong with that terminal. He says, that's not supposed to be grounded there. That's just an attachment point. So I went in the bin, and when I went through the bin, I found different types in the same bin. and it wasn't me. It was the terminal. You know, I couldn't find it though. But that's the stuff you find in life. Life is crazy. You know, a lot of times you'll sit there and think you're losing it, but you know what? Maybe you're not as crazy as you think you are. I stayed with this thing. I got it to this point. I think that's it. All right, that's it.